Hello, good morning, classmates and teacher. I am David Retier Rivera, and in this presentation, we will delve into the topic the future of the CRISPR gene editing according to the Plant Science, as published in the journal iScience. And we will explore how this revolutionizing agriculture. Global food production is facing increasing pressure from various external factors: climate change, population growth, and escalating water scarcity pose significant change to the agricultural sector. Climate variability is projected to intensify due to the global climate change, linked to the emergence and heightened prevalence of both new and existing plant virus and increased pest pressures. And these factors have the potential to diminish agricultural productivities and compromise food security. The global population is anticipated to reach 9.7 billion to 2015, um, substantially amplify the demand for food compared to 2010 levels. However, as the rate of yield improvement through conventional breeding methods slow down, thus arising necessary for novel breeding techniques to ensure global food security. New plant breeding techniques have emerged in response to the mounting global food demand and environmental change associated with agricultural production. These techniques encompass a range of methods such as single-finger nuclease, oligonucleotide oligonucleotide direct, mutagenesis, genesis, and trigenesis, RNA depends DNA methylation, grafting on GM store root, reverse breeding, agro-infiltration, and citing genomics. Generating technologies enable plant scientists to modify the lead and or add genetic material at precise location in the genome of the living organisms. Key decisions between GM and GAD technologies include the precision of the GAD in affecting site direct insertion in the DNA and the less frequent intrusions in foreign DNA from another organisms in gene editing technologies. Although CRISPR gene editing holds promise to bolstering food security and enhancing agriculture's sustainability, there exists impediments to its um, adoption and dissemination. This study seeks to garner scientific opinions across potential regions where CRISPR could be employed, encompassing both the private and public sector and encompassing various groups to the present consolidate perspective on the primary drivers, barriers and prospects of CRISPR gene editing. Understanding the potential of CRISPR from those involved in this evolution can provide valuable insights into the future. Controversy over CRISPR gene editing application in agriculture. Existing research has identified several functions of CRISPR technology that could address food insecurity through plant breeding. These include traits like herbicide resistant, drought resistant, and intrinsic nutrients content, which could enhance cultural agriculture sustainability and food security, particularly in low-income countries. Despite these potential benefits, CRISPR technology face challenges and controversial similar to GMOs, consumer regulation issues, and technical barriers hinder these widespread adoption and commercialization. However, some countries are adopting alternative regulatory approaches to as crisping edited crops. Understanding the potentials, the barriers of crisping technology is crucial for its future implementation in commercial agriculture. Further research is needed as its feasibility and impact to regional and global levels. Now in the part of the results, as we can see the table one, the distribution of the survey result in 1040 inquiry response, of which 679 69 were used in the study of the everything in the sample. 371 response were not used for comparison for one of two regions. Given the length to the survey and total recade our response shorter than 2 minutes. 47 response were eliminated. Additionally, response with the complete completion rate um, less than 90%. 324 response were removed, and a summary of the profile variables linked to the 669 participants in the study can be found. African plants scientists rated drought resistant, insect resistant, fungus resistant, and berry resistant, and the function the crisping generating with the highest probability of successful implementation in their region. In Asia, fungus resistance and virus resistance were the highest rated function according to plant scientists active in this region. Plant scientists with research programs focusing on European agriculture, drought resistant, insect resistant, fungus resistant, and virus resistant uh, were the most likely function to be successfully implemented. North America plant scientists dedicate the herbicide resistant will likely be be the most successful fusion. The only fusion score exciting the fire carols all region the sector the sector. Um, the four regions denote significantly higher score for fungus resistance and virus resistance and probably because of the step increasing in prevalence of virus and fungi in agriculture to the climate change through um, resistance and insect resistance were reported as potential function as CRISPR particularly important for Africa and Europe. Um, Whereas Erythra's resistance appears to be dominant in North America, according to the plan in Sciences. Fusion and CRISPR are regional comparison. Table highlights the mean score on the potential of successful implementation of the possible fusion of the CRISPR gene editing separated by region and sector. Response rated the fusion on a 7-point probability escalate. Um, this right didn't set out to explain why social in was important, but rather what issues which and functions and plant scientists thought will be successful addressed by CRISPR. African plants scientists varied drought resistance, insect resistance, fungus resistance, and resistance, and the function the CRISPR gene editing with the highest probability of successful implementation in their region. In Asia, fungus resistance and virus resistance were the highest rated function according to plant scientists active in this region. Plant scientists with research programs focusing on European agriculture, drought resistant, insect resistant, fungus resistant, and virus resistant uh, were the most likely function to be successfully implemented in North America. Plant scientists dedicate the herbicide resistance will likely be the most successful fusion. The only fusion score exciting the fire carols all region the sector. Um, the four regions denote significantly higher score for fungus resistance and virus resistance, and probably because of the step increasing in prevalence of virus and fungi in agriculture to the climate change through um, resistance and insect resistance were reported as potential function as CRISPR particularly important for Africa and Europe. Um, Whereas Erythra's resistance appears to be dominant in North America, according to the plan in Sciences. Fusion as CRISPR are fully private comparison. There was more consensus on the potential benefits when comparing private versus public scientific the comparisons tools from across heterogeneous geographical regions, public sector scientists rated herbicide resistance, drought resistance, fungus resistance, and virus resistance as the most likely functions to be implemented successfully. Regardless of the region they were expect to be implemented. At the private sector level, insecticides resistance, fungus resistance, virus resistance, increased shelf life were prevails as the functions with the highlights highest probability of successful implementation. The public the private sector rather multiple fusion of CRISPR and similarity. Different mainly lay in the fact that the public sector inside systems uh, uh, with herbicide resistance and drought resistant as feasible fusion of CRISPR, whereas the private sector rather trace no significantly higher. Crop benefits of CRISPR implementation are regional comparison. In Table 3, the result on the benefits of CRISPR of benefits crops are present by region and sector. Responder rated 8 crops on the 7-point scale of likelihood in the all regions except Oceania, Masai, and soybean were expected to benefit from CRISPR gene editing, with score significantly higher in their all regions except for Africa and Oceania. Furthermore, rice was expected to benefit significantly more compared to the other crops in Asia, North America, and South Africa. Potatoes were experienced accepted to benefits in Asia, Europe, and North America, whereas cassava in the line with crops production context was only expected to benefit from CRISPR gene and editing in Africa. And crop benefits of CRISPR implementation, a public and private comparison. Looking at the sectoral level, compared the results were found between plants, the scientists' views from the public and private sector. In the both sector, with maize, soybean, and potatoes scored significantly uh, higher than other crops. The only difference between the two sectors was the fact that a significantly higher result emerged for rice in the public sector, whereas in private sector no statistical difference uh, were found for rice. Barriers of CRISPR adoption and regional comparison. Table 4 shows the perceived barriers of CRISPR gene editing implementation across different regions and sectors. The survived participant rated 9 barriers on the Likert scale from 1 to 7, which result in the mean score from every barrier. Across all regions, consumer reception was considered as significant issues implementing the potential of adoption of CRISPR. Policies and legal issues were also rated significantly higher than the most uh, weighted average of the responsibility region in the whole region, except South American. Um, intellectual proprietary rights issues were rated as highly implementing in Asia, Europe, and North America. Uh, Although the technology is different from GM, the same impediments seem to the appear from gene editing crops. And not surprisingly, we see the high development costs were considered to be a variety in African and South American, in contrast of target effects score significantly lower in the whole region except Oceania. In this could be a fusion of target effects can also occur, and in the some case at the higher rate in the natural mutation or routinely used breeding techniques such as regular crossing on the undirected mutagenesis using to cease culture, seminal mutagens, or radiation. The barrage RNA design received lower score as well in the all regions, except in South America. Lack of the infrastructure and technical experience, experts had low scores in the most developed regions, in the terms of CRISPR gene editing. Barriers of CRISPR adoption and public-private cooperation. The public and private selector plans scientists exhibit similar patterns, and when it comes to the perception of barriers of CRISPR gene directing adoption, the key difference is that the private selector considers high development costs as a more impeding barrier compared to all another barriers where the public selector doesn't. This could be because CRISPR system come free of charge from for public research of uh, as long as no commercialization is present. Data analysis and statistical testing. After collecting the response, statistical analysis were performed on the different variables of the super question. All the questions were answered on the scale from the 1 to 7, and consequently, a mean score could be from every variable in the survey separated to by region and sector, and all described statistics were started from qualitative and compared. Quart-sized t-tests were used for future analysis. Um, the statistical analysis focused the three questions: fusion from CRISPR, barriers of CRISPR implementation, and crowd benefits of CRISPR application. For each variable, a weighted average mean was calculated from all the scores given by the responsible per region and sector. Variable score was compared to the weighted average mean within this region or sector, using a pairwise side t-test. In this way, outlining a score could be the lead score, which significantly different from the weight average for all scores. For example, results can be compared for barriers of CRISPR adoption in Africa, or the benefits of CRISPR in North America. Using this method, we assessed whether the response rated centrifusions, variants, and crop benefits significantly higher and or lower, higher or lower to others separated by region and sex. Significance to a level of 5% was used for all tests. The results of significance and relevance use the multiply comparison correction. The p-values estimate were adjust p-values using Benjamin Goldberg BH methods. Pairwise, the tests were only run within a region or sector, as comparing between region and or sector is difficult because of major concept difference. Whatever is the research draws picture of where the major difficulties, opportunities, and benefits of CRISPR gene editing lie by region and sector. Discussion and conclusion: CRISPR gene editing has as one of the main MPBTs has emerged as the potentially effective tools to address the growing changes in the global food demand in sustainable development. Despite this potential, the growing evidence in the research and development, this application to the food groups has led to the growing controversy in the line to the concern that feed in the public debate on GM's technology. This article contributes to the limited research on the perception of the non-consumer by targeting plant scientists. Although the Starfield portfolio theme of 669 responses cannot be considered a responsibility for the plant breeding sector. We have elected opinions of the plant scientists worldwide, covering all regions and including representatives from the private 25% and the public sector 66% or both 9%. To all participant plant scientific things could be working with MPBTs, it's important to emphasize that our findings reflects their subject perception on the various functions and benefits of the CRISPR genes editing groups. However, some variables will ultimately be avoided when a specific CRISPR application will be introduced in the region, or whether a specific function will be effectively targeted through CRISPR is yet to be seen. Across the board, plant scientists viewed consumer perception to be the most impeding barrier in the CRISPR adoption. Policy legal issues were seen to be a significant barrier across all regions except of South America. This could be explaining because of the fact that multiple South American countries had allowed genome editing crops to the ground, such as the production of rice oiled soybeans in Argentina. This the plant scientists working in Europe denoted the highest scores for police legal issues out of all regions and both sectors. A precise explanation for this high score of Europe on police legal issues could be that the European Union has a structured regulation for CRISPR gene editing crops by making them subject to GM regulation. Intellectual property rights issues were found to be a significant barriers in Asia, Europe, and North America, the region which hold hold the most CRISPR parents in the market. This might be because of the fact that given the large amount of CRISPR parents, there is the likely a large amount of copyright infringement of money spent on legal matters and protecting the intellectual property. High development costs are the signal barren by Africa and South American sciences, both regional populated with a high number of developed countries, which likely are plagued by lower relative short development budgets. In European and North American development costs were no precede is an issue. This could be because of the previous research from genetic editing created a much smaller reputation market area, 96% smaller, to break being even on the financial investment and when compared genetic modification for the same tribe value per hectare. The study highlights significant barriers to the commercial adoption of CRISPR gene editing technology worldwide. Consumer education and the influence of the clear regulator uh, from work post-major college across regions, high-income countries require robust intellectual property rights frameworks, while developing nations face funding constraints, but the public and the private sector encounter obstacles related to the consumer perception, police, legal issues, and intellectual property rights. Fungi virus resistance are identified as the most promising application of CRISPR in the agricultural production globally, with drought and insect resistance also crucial, especially in Africa and Europe. Maize and soybean are expected to benefit the most from CRISPR, followed by wheat and rice and potatoes. Consumers accepted the GMs and products that offers tangible benefits such as increasing nutrition, inflation, and CRISPR potential impact. Despite CRISPR potential to address food insecurity and improve agricultural sustainability, concerns persistent among plant breeders regarding consumers' perception, legal frameworks, and development goals in the low-income countries. Achieving CRISPR full potential requires raising consumer awareness, policymakers' understanding of these benefits, more supports, including economics, legal, and politics backing, is essential for the widespread adoption for CRISPR technologies to address global change in the agriculture.